Alright, so number 16 is y equals negative natural log of x plus 2. My reference points are 1, 0, and base 1. In this case, the base is e, because it's a natural log. So first things first, so a is negative 1. It's right here, the coefficient of the natural log. So that means that I'm going to multiply my y's by negative 1. So 0 times negative 1 is still 0. And 1 times negative 1 is negative 1. Now the h value is 0 because there's nothing in parentheses inside with the x, and the k value is 2. Okay, so that means that all we're going to do now is we're going to add 2 to the y's, nothing to the x's. Okay, so the x is going to stay 1, and then the y is 2 plus 0 is 2. The e is just 2.7, and then 2 minus 1 is 1. So these are the points we're going to graph. Alright, so for this problem, since h is 0, that means that the vertical asymptote is x equals 0. So it's right here, right over the y-axis. Okay, and then we plot the points 1, 2, and 2.71. So 2.5, 2.71, about here. Okay, and use those 2 points to draw your curve. So it's going to go something like this, like that. So the domain is all x such that x is greater than 0. The range is all reals, again, because natural log is a log function, which is the inverse of an exponential function. The vertical asymptote is x equals 0, and the end behavior is as x goes to 0. Again, remember, end behavior, we're describing what's happening here and what's happening here. Okay, so as x goes to 0, y goes to infinity. So as we go to the left towards 0, y goes up to infinity. And as x goes to infinity, y goes to negative infinity. I know it doesn't show it here, but this graph, this curve right here, is eventually going to cross the x-axis and keep going down. Down, down, down forever. Whereas on the left side, this point right here is just going to get closer and closer to 0. It's never going to cross this line. Okay, it's never going to cross over. So it's just going to get really, really close. And that's it for this one. Alright, so number 17, the a value is 2, the h value is 3, and the k value is 0. Okay, so that means that we're going to multiply our points, the y values, by 2. So right here I'm going to multiply by 2. So I get 1, 0, because 0 times 2 is 0, and then 1/2, 2, because 1 times 2 is 2. And then in the next one, I'm going to add the x's by 3. I'm going to add 3 to them, and nothing to y, because because k is 0. So then 3 plus 1 is 4, and then 3 plus 1/2 is 3.5. Oops, 3.5. Then the y stays the same. Okay, so there are your 2 points. Now we're going to graph them. Okay, so now we're going to draw the vertical asymptote, which is right here at x equals 3. So let's see, use red. So 1, 2, 3 goes right here. Okay, so this is the line that's going to keep your graph in the right spot. You're not going to cross over that line x equals 3. And now we're going to plot the points. 4, 0, and 3.5, 2. So 3.5, 2 would be about, say that's 3, 3.5, about here. Okay, so with that, we connect the points. It's going to be very steep. It's going to go something like this. Okay, so the domain is all x such that x is greater than 3. The range is all reals. Vertical asymptote is x equals 3. End behavior, for that, we describe what's happening here and here. So we say as x goes to 3, y goes to infinity. And as x goes to infinity, as we go to the right, y goes down, so we put negative infinity. Okay? And that's it for that one.